Hello, welcome back. So today we are going to talk about numerical integration. So, before we have done analytical method, we have developed so far some integral cannot be used, technique cannot be used to evaluate a definite integral. For example, an integral may not have an obvious antiderivative, like such as if you see the integral of cosine x squared or the integral of 1 divided by ln of x, or perhaps the value of the integrand is known only at a finite set of points. Yeah, so on this section, when analytical method fails, we often turn to numerical methods, which are typically done on a calculator or computer. These methods do not produce exact value of definite integral, but they provide approximations that are generally quite accurate. Many calculator or software packages and computer algebra systems have built-in numerical integration method. And in this section, we explore some of this method. But so far, let's start with absolute and relative error. So the error that you can, since it does not give you the exact value, what is the error? So suppose C is a computed numerical solution to a problem having an exact solution X. There are two common measures of the error in C as an approximation to X. Absolute error is equal to what? Absolute value of C minus X. And relative error is absolute value of C minus X divided by absolute value of X if X is different from 0. So let's start with our first example. You can see the ancient Greeks used 22 divided by 7 to approximate the value of pi. Determine the absolute and relative error in this approximation to pi. So that's easy. We use what 22 divided by 7 to approximate the value of pi. So pi is the exact value. 22 divided by 7 is the approximate value. So, and this section is a little bit longer, so bear with me. So absolute error will be equal to the absolute value of 22 divided by 7 minus pi. Then you use your calculator, okay? And give me the answer to probably 5 decimal places, which would be what? Approximately 0.00126. And the relative error will be absolute value of 22 divided by 7 minus pi divided by pi, which is approximately 0.000402. And in percentage, this will be what? So that means the error is 0.04%, basically. Okay? So after this one, we will talk about the midpoint rule. So many numerical integration methods are based on the idea that underlie Riemann sums. So if you remember the Riemann sums for recall, this method approximates the net area of region bounded by curves. A typical problem, if you have to find the area, so you would divide it to a equal small triangle with the same length and then add them, so that will give you your sum. So the definition, you can see, suppose f is a defined and integrable on the interval a to b, close interval a to b. The midpoint rule approximation to integral of a to b f of x dx is using n equally spaced subinterval on the closed interval ab is mn. Then look, m sub n is equal to f of m1 times delta x plus f of m2 times delta x plus, and so on up to f of mn delta x, which will be equal to what? The sum which is the sum of f of x sub k minus 1 plus x sub k divided by 2 times delta x from k is equal to 1 to n. So you need to know this is the summation notation, okay? This one right here is the summation notation, which is also called sigma in Greek. It's a Greek letter sigma, which means S. So to read is the sum of f of x sub k minus 1 plus x sub k divided by 2 times delta x from k is equal to 1 to n, where your delta x is what? B minus a divided by n, and x0 is equal to a, xk is equal to a plus k times delta x, and m of k is x minus k1 plus xk divided by 2 is the midpoint of x sub k minus 1 xk for k is equal to 1 to n. So this is what it means. You can see, let me make this bigger a little bit so you can see. So you can see if we have to find the area of this from A to B, you see from A to B, right? So this is what M1, M2, M3 means. So those are what the midpoint between A and X1. The midpoint between X1 and X2 is called M2 and so on. So you would see all the width are the same. So the length is what changed based on the graph. That is f of mk. You see f of m1 is f of m1 is different from f of m2 is different from f of m3 and so on. But if you look, a to m1 is the same, m1 to x1 is the same, the distance. Okay, so like for example, let's do the first example, which is approximate the area from 2, the integral from 2 to 4 x squared dx using the midpoint rule with n is equal to 4 and n is equal to 8 sub interval. Okay, so my solution will be, we know a is 2, b is 4, right? With a is equal to 2 and b is equal to 4, and n is what? We will take n is 4 first. N is 4. So let's find the subinterval. We have, the length of each subinterval, which is what? Delta x. So my delta x, again, you just follow the rule. Delta x we said is what? B minus a divided by n. Look, delta x is b minus a divided by n. So my delta x, which is b minus a divided by n will be equal to 4 minus 2 divided by 4. So that will give me what? 0.5, right? Which is 1/2 0.5. So now you first know, again, don't mind my graph, okay? This x squared, so the graph is just like this. So if I said this is like 2, and let me use this to be 2, and right here we have 4, right? So we are dividing into what? My delta x is 0.5. So of course, the first point will be 2.5, 3, and then 3.5. Don't worry about my graph, okay? So it's just like this will be 2.5, this will be 3, and this will be 3.5. But we are using what? Midpoint. So what will be the midpoint? The midpoint here will be, the midpoint between 2 and 2.5 is what? 2.25, right? Because if you look to find this area, it will be something like this. Look. This is the area. So I'm taking time to explain this part to you, but the rest I will just graph quickly, okay? This is the area that will be, you can see based on the graph, do you think the area will be more than the exact area or less than? So now when we talk about the midpoint, so the midpoint between 2 and 2.5 is what? That is 2.25. That's what my M1 will be. And the midpoint between 2.5 and 3 is what? That is 2.75. So my M2 will be 2.75. And the midpoint between 3 and 3.5 is what? That would be my M3, which is 3.25. And between 3.5 and 4, the midpoint will be 3.75. So M4 will be 3.75. Okay? So basically, we know x0 will be 2, x1 will be 2.5 because subinterval, x2 will be 3, and x3 will be 3.5, and x4 will be 4. So since we are talking about the midpoint, so we know the integrand must be evaluated at the midpoint. Right, so the midpoint, which we found M1, between 2 to 2.5, between x0 and x1, the midpoint is what? 2.25. M2 is 2.75. M3 is 3.25. And M4 is 3.75. So we have to find f of M1. Again, look, I'm just using the formula that is given to you here. You see, is f of M1 times delta x plus f of M2 times and so on. That's what you used when we are looking for the midpoint. So we have to find f of M1. So we know first, do not forget, we know f of x is what? X squared, and n is what? 4. So using the midpoint, we said m of 4, that means n is 4, will be equal to what? F of M1 times delta x plus f of M2 times delta x plus f of M3 times delta x plus f of M4 times delta x, right? So we need to substitute this M1, which is 2.25. So basically, what this means is my M of 4 will be f of 2.25. We know delta x we find is what? 0.5. So if you want, since every term will be multiplied by 0.5, we can just factor our 0.5, okay? So I'm going to use a bracket, and then because delta x is what? 0.5. So everything will be multiplied by delta x plus f of M2 is what? M2 is 2.75 plus f of M3, which is 3.25, plus f of M4, which is 3.75 times my delta x. I know delta x is 0.5, right? So now, look, you use your calculator. You substitute 2.5 for x on f of x. So 2.5 square. We will get 2.25 square plus 2.75 square plus 3.25 square plus 3.75 square, then times 0.5. Use your calculator and you will see it will give you 18.625. Right? So again, or we can go ahead and find the exact area as well if you want. That's in this case, we can find the exact area because we are looking for finding the area of what? The integral of 2 for x squared dx. So we know this would give me what? The antiderivative of x squared is 1/3 x cubed 224. And if you substitute, you will see this one will give me 56 divided by 3. That's the exact area. That's the exact area. This is the approximation using what? The midpoint. So that's why now if I want to know the absolute error, so I can find the absolute error, right? You can see, even if that question is not asked, the absolute error will be equal to what? 18.625 minus 56 divided by 3. Use your calculator. That will give me exactly what? 0.0417. Or you can also find the relative error, which would be absolute value of 18.625 minus 56 divided by 3 divided by 56 divided by 3, which will give me 0.00223. And that is what? 0.2223%. Okay. Any questions so far? So that's how you use the midpoint. I will use exactly the same thing with M of 8. Okay. We'll use exactly with the same thing with M of 8. So again, to find M of 8, do not forget A is 2, B is 4, and N is what? 8. So in this case, my delta X will be equal to 4 minus 2 divided by 8, which is 1 divided by 4, and that is 0.25, right? So in this case, M of 8 will be equal to f of M1 times delta X plus f of M2 times delta X plus f of M3 times delta X plus f of up to what? Plus f of M8 times delta X. And what is my M in this case? Of course, X1 will be 2, but I mean X0 will be 2, X1 will be 2.25, X2 will be 2.5, and so on, right? So you will see your M1 will be what? You add these two and you divide by 2, okay? You add 2.25 plus 2 and you divide by 2. That would be the midpoint of which would be M. Okay? So M1 would be 2.125, and you can go ahead and find M2, which will be what? Between X1 and X2. So you add 2.25 plus 2.5, and then you divide that by 2, which will give me 2.375, right? You do exactly the same thing, and then you will see M of 8 will give you what? 18.65625. Okay, that's how you use the midpoint. So now next, let's talk about I don't want to spend too much time because we are going to repeat the same thing, but if you want, I can write it down so you can see what it really gave it to you before the solution. So before I give you the solution, my M of 8 will basically be f of 2.125 because that's the midpoint, we can factor delta x plus f of 2.375 plus between x2 and x3. X3 will be what? 2.75, right? 2.5 plus 2.75 divided by 2, and then so on up to the last one. I'm going to write the last one. So you would see M3 is what? Between 2.5 and 2.75, right? So that would give me f of 2.625 plus, again, you have to do all 8, right? And M4 will be what? Between 2.75 and 3. So that will give me f of 2.875 up to what? M8, which is 3.875 times delta x. And then once you do all of this, you will see your M of 8 would be 18.65625. Okay? So now let's talk about the definition, the trapezoid rule. So the trapezoid rule means what? Suppose f is defined and integrable on the closed interval a to b. The trapezoid rule approximation to the integral from a to b f of x dx using n equally spaced subinterval on the closed interval a to b is Tn is equal to 1 divided by 2 f of x0 plus the sum of k is equal to 1. Plus the sum of f of xk from k is equal to 1 to n minus 1 plus 1/2 f of xn times delta x, where my delta x is always what? B minus a divided by n, and where xk is what? A plus k delta x for k is equal to 0, 1 to n. So this is the trapezoid rule, okay? The area of the curved trapezoid is what? F of x sub k minus 1 plus f of x sub k divided by 2 times delta x to find this area. Okay? And the trapezoid rule, which is so you can see the approximation is 1/2 f of x0 plus f of x1 plus so on up to f of xn minus 1 plus 1/2 f of xn times delta x. So let's use that to approximate the same area using the trapezoid rule with n is equal to 4 subinterval. So again, solution. So the grid will not change. We know A is 2, B is 4, and n is equal to 4. So our delta x will be what? 4 minus 2 divided by 4, which is 0.5. So same thing, the grid point are what? x0, which will be 2, x1 will be delta x is 0.5, so 2 plus 0.5 is 2.5. X2 is 3. X3 is 3.5. And X4 is 4. With what f of x is? With f of x is equal to x squared. So the trapezoid approximation rule said so the trapezoid rule, which is T4, will be equal to what? 1/2 f of x0 times delta x plus f of x1 times delta x plus f of x2 times delta x plus f of x3 times delta x plus 1/2 f of x4 times delta x. So again, we can factor delta x, right? We can factor delta x. What is my x0 is what? 2. So 1/2 times 2 squared plus f of x2 is what? F of x1 is what? 2.5. So plus 2.5 squared plus 3 squared plus 3.5 squared plus 1/2 times 4 squared times delta x. My delta x is what? 0.5. So if you use, you would see this one will give me what? 18.75. We know the exact value is what? 56 divided by 3. So you can again find the relative error and the approximate error if you want, using the same thing, okay? So the next example is a problem. It said the table below show that data for the rate of world crude oil production in billions of barrels per year over 16 years period. If the rate of oil production is given by, they assume to be integrable function R, then the total amount of oil produced in billions of barrels over the time period from A less than or equal to T, which is less than or equal to B, is Q is equal to the integral from A to B RT dt, using the midpoint and trapezoid rule. Use the midpoint and trapezoid rule to approximate the total production between 1995 and 2011. So the table is given to me, right? So first thing, let me write my solution right here. For convenience, we will set first. What we will set let T be equal to 0 represent what? 1995, and t is equal to 16 represent, those are time, right? 2011. And we let RT be the rate of all production in the year corresponding to T. So you can see we have basically this mean T is 0, T is 1, T is 2, and so on, right? So now, so you can see R0 is what? 21 point, R0 is 21.9, R1 is 22.3, R2 is 23.0, R4 is 23.7, and so on. Okay, so basically they did not give us ask to find, they just asked use the midpoint and trapezoid rule to approximate the total oil produced between 1995 and 2004. So we have what if we first choose n is equal to 4. So let's choose that first, okay? Because they did not specify to use how many sub-interval. So I'm going to use n is 4 first. Then we know if n is 4, then delta t will be what? It will be 16 minus 0, which is 16 divided by 4. So that will be 4 years, right? So the result for the midpoint will be what? We'll be dividing by 4. We'll be dividing everything by 4. Since we are practicing, I will start from n is 4 and then we'll go from there, okay? So again, in this case, using the midpoint, so Q will be approximately M of 4, which will be what? Bracket M of 4 is 4 interval. So every what? 4, so midpoint of R4 will be what? We have from 0 to 4. 0 plus 4 is 4 divided by 2. It will be what? 2. So R of 2. Does that make sense to you? Because n is 4. So if n is 4, the first one would be from t is equal to 0 to t is equal to 4. So you take 0 plus 4 is 4 divided by 2 is 2. So R of 2 will become what? Again, 23. If I'm using 23.0 plus, the next one would be from R is 4 to R is 8. 8 plus 4 is 12 divided by 2 is 6. So R of 6 plus R of 10. Then finally plus R of 14 times delta x, delta t, sorry, delta t. So which will just be R of 2 is 23. Let me use as it is on the thing so you know exactly what I'm talking about. So this one will give me 23.0 plus R of 6. R of 6 is what? You count T is 6, 2, 3, 4, 5, 6. That is 2001, which is 25.2 plus 25.2 plus R10. R10 is 25.9 plus R14, which is 26.4 times delta T, which is 4. So M4 will be what? Use your calculator. M4 will be 402. And of course, Q, when using trapezoid, Q. So let's use trapezoid again. Q will be approximately T of 4, which will be 1/2 R0, R of 0, plus R of 4 plus R of 8, right? Plus R of 12 plus 1/2 R of 16 times delta T. Why? Because for the trapezoid, we use all the, we just add delta T. So start from 0 plus 4 plus 4 and plus 4 and so on. So, which would be 1/2 R of 0 is 20, R of 0 is what? 21.9. 21.9 plus R4, which is 24.5 plus R8. R8 also is 24.5 plus R12, which is 27.0, then plus 1/2. R16 also is 27 times delta T, which is 4. And then our T4 will give us approximately 4.18, right? So we can move again to check when n is 8. And I'm going to give you a formula. When you know trapezoid, when you know the midpoint, sometimes you can easily find for n is equal to 8 subinterval, so we can see delta T will be in that case what? 2, because delta T will be 16 divided by 8, right? 16 divided by 8, which would be 2 here, right? So again, I'm going to use again same thing. Then Q would be approximately equal to M of 8, which would be, in this case, M of 8 will be parentheses, it will be every 2 years. So which mean 0 to 2. 0 plus 2 divided by 2 is 1. R1 plus R3 plus R5 plus R7 plus R9 plus R11 right, plus R13 plus R15 plus R15 times delta T. Right, if you count, you can see we have 8, 1, 2, 3, 4, 5, 6, 7, 8, right? So now you substitute everything, R1 plus R2 plus R3, you will see your M of 8 will be equal to 3, 9, 9.8. Okay, and if you do the same thing for trapezoid, you would see, I pause the video and do this one, you would see for the trapezoid, T of 8 also will be what? 401.9. Okay, so once you do both, I want you to know this rule. Okay, once you know, if you know Tn and Mn are known. Okay, let me, if you want, you can go ahead and find M of 16 and T of 16 as well if you want to. Okay, but you need to know if the midpoint of n subinterval is known and the trapezoid of n also are both are known, then the next trapezoid rule approximation is T of 2n will be equal to Tn plus Mn divided by 2. You can verify like T of 8. We can find it because we already know M of 4 and T of 4. So you can just substitute and you will see it will give you T of 8. Like what I mean is this mean example, to find trapezoid of 8, it will be equal to trapezoid of 4 plus divided by 2, or you can see we find both of them, right? The trapezoid of 4 we find is 4.401.8 plus the trapezoid of 4, I mean the midpoint of 4 we find that's 402 divided by 2. You see it will give us exactly 401.9. Okay, so I will let you do T of 16 and N of 16. Okay, so which mean basically since we know T of 8 and M of 8, we can easily find T of 16 as well. Do you understand? That's the point. So now let's do the last one, which is the definition Simpson's rule. Suppose f is defined and integrable on the closed interval a to b, and n is greater than or equal to 2, is an even integer. The Simpson rule approximation to the integral from a to b f of x dx using n equals space and subinterval on the closed interval a to b is Sn is equal to parenthesis f of x0 plus 4 times f of x1 plus 2 times f of x2 plus 4 times x of 3 plus so on plus 4 times f of xn minus 1 plus f of xn divided by delta x divided by 3, where n is an even integer. Delta x is always b minus a divided by n, and xk is what? A plus k times delta x, for k start from 0, 1, and minus 1. Same thing, you see the Simpson rule is used like this. Okay, you can see you have your x0 is equal to a, xn is equal to b. So do not forget x1, f of x1, and so on. So let's use the Simpson rule to solve this problem. Okay, we have what? Example, approximate the integral from pi divided by 2 to 5 pi over 2 since x divided by x dx using the Simpson rule. Okay, that's a typo, using Simpson rule with n is equal to 4 sub-interval. Okay, so again, this solution, first thing, let's find our delta x, because we know a is pi over 2, b is 5 pi over 2, then delta x will be 5 pi divided by 2 minus pi divided by 2 divided by 4, which will be pi divided by 2. Okay, and therefore the grade will be what? X0 will be pi over 2, x1 will be pi, x2 will be 3 pi over 2, x3 will be 2 pi, and x4 will be 5 pi divided by 2. Of course, let's not forget with what is our f of x? F of x is since x divided by x, and n is 4. So the Simpson rule said s of 4 will be equal to what? Parenthesis f of x0 plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3. So this one will be have continue, we'll switch 4 and 2 until the last one. The last one is x4 in this case. So we'll have plus f of x4 times delta x, which is delta x is what? pi over 2 divided by 3. So this will give us my f of x is what? Sine x divided by x. And we know x0 is pi over 2. So it will give me sine of pi over 2 divided by pi over 2 parentheses plus 4 times sine of pi divided by pi plus 2 times sine of 3 pi over 2 divided by 3 pi over 2 plus 4 times sine of 2 pi divided by 2 pi plus x4, which is 5 pi over 2. So sine of 5 pi over 2 divided by 5 pi over 2 times pi divided by 6. Using your unit circle now, if you use your unit circle, you will get what? Sine of pi over 2 is 1. 1 divided by pi over 2 is 2 divided by pi minus, plus sine of pi is 0, right? 0 times 4 is 0, divided by pi is 0, plus sine of 3 pi over 2 is negative 1. Negative 1 times 2 is negative 2. Negative 2 divided by 3 pi over 2 will give me negative 4 divided by 3 pi. So minus 4 divided by 3 pi. Sine of 2 pi is 0. 0 times 4 is 0 divided by 2 pi is 0. So that would give me plus 0. Sine of 5 pi over 2 is 1. 1 divided by 5 pi over 2 is 2 divided by 5 pi times pi divided by 6. So we know pi will cancel with this factor pi. So basically, I will be left with what? Combining everything, and we'll have 8 divided by 45, which is approximately 0.178. Okay, you can find the absolute error and so on. So, but before I let you go, you also need to know, same thing as I gave it to you. You know, we just said T2n is what? T of n plus m of n divided by 2, right? So you need to know, if you already have the trapezoid rule approximation Tn and T2n, the next Simpson rule approximation follow immediately with a simple calculation. S of 2n is equal to 4 times T of 2n minus Tn divided by 3. This is what you need to know for this section. I will see you in the next one.